Okay, let's look at how to value benefits and costs. We will first look at a number of principles we want to follow in doing so, and then look at how to treat particular items. First principles, CPA considers the efficiency of a project in terms of the nation's welfare. Thus, all costs and the benefits must be defined in terms of how they impact on the nation overall, and not just on the individuals, though they might coincide if there's no externalities. So so here is about the standing point of CBAs. So we are standing at the society's point of view. Second, we are measuring flows of benefits and costs, which are caused due to either directly or indirectly by the project, due to this project. And importantly, these flows must be incremental or marginal to the projects in addition. For example, you can ignore the fixed overheads if they are not incremental to the project. And benefits which would have flowed anyway are ignored. Again, it's not incremental to the project. It will occur, okay, even without the project. Costs and benefits which take place before the evaluation of the project are ignored because they are kind of sunk. You cannot say your project is going to start today. That's the assessment date. That's time 0. Then everything happened before time 0. So say you have spent $500 yesterday on looking at the feasibility of conducting this project. Then you want to ignore this $500 because you cannot recover them. You cannot turn back the clock. Okay. Third, strictly speaking, the timing of benefits and the costs are deemed to take place when the resource flow takes place. Okay, so what's important is that is the point where the resource flows actually take place. Though this is often when money is received or paid. Okay, so we say I'm going to purchase trucks to use in my dam project. Then one truck, suppose, is $50,000. Then you record this $50,000 costs at the time when you paid it. Okay, or actually more accurately, it should be at the time when you actually get the truck, put the truck into the project. This is not when contracts are entered into. Okay, for example. Fourthly, as far as possible, the benefits should be valued at the maximum amount that people are willing to pay for them. And if we are looking at the costs, we want to value them at the minimum amount people are willing to receive for the goods or service, or minimum amount of producing these items. All right. Fifth, the streams of benefits and costs must be discounted back to time 0 to allow for time preference. Okay, so this formula, we will talk more about this discounting in the next topic. But this formula is very important. So it's the workhorse for the computational MPVs. So the point, one feature of the cost-benefit analysis is that a project usually lasts for many years. So $1 in 20 years time and $1 in today's times, they are different. So we got to discount them back, discount the $1 in 20 years time back into present time, so that we can compare apple with apples. Okay. 6. The benefit that consumers received from a project is the consumer surplus that consumers enjoyed from consuming this product. In principle or conceptually. In practice, this could be very difficult to measure. So frequently we just use, suppose I'm going to evaluate a hydroelectric dam project, and one item of benefits is the electricity generated by this project. Okay, frequently, conceptually and principle, the dollar value of this electricity should be consumers' willingness to pay for this electricity generated by the project. Frequently, we're gonna measure this by the price of electricity times the quantity of electricity due to this project produced by this dam, this project. And this is true if we have this condition. If for example, if these electricities are exported to another countries, okay, so we can just use this one, this price of electricity times the quantity of electricity due to this project. So when we are valuing benefits in efficient markets where the project does not affect the market price. Okay, for example, again, the electricity, the hydroelectric dam project. So suppose it's small compared with the electricity market. So the electricity that this dam project generated does not affect market price. In such cases, again, we can just measure the benefits of this item of benefits as quantity of apples times the market price. For example, like this diagram. So the demand is horizontal. So electricity can be sold at the market price of PO as many as we want. And this is a supply curve without our project. This is a supply curve with the project, the hydroelectric dam, the hydroelectricity dam project. Okay, and this project produces this many units of electricity at the price of this. Then the benefit is just the price times the quantity. However, when we are valuing benefits in efficient markets where the project does affect the market price, in these cases, the benefits is not the same, it's not equal to quantity outputs from the project times the market price. And hopefully this discrepancy would be small. For example, like this one, so downward sloping demand function, and this is the supply without the project, this is supply with the project, they are not the same. So now we cannot really use this to measure the benefit, but hopefully the difference is small. Okay, 7th principles. Opportunity cost must be used in measuring the costs of the project. So here, some items of costs are explicit, which means money is paid. So it involves money flowing out of your pocket. In such case, the opportunity cost is just this money cost, and usually we won't forget it. But for some items, it does not involve money flowing out of your pocket. So we commit these resources, these items costs into this project. There's still opportunity cost, because otherwise we can use elsewhere. All right. So public policies usually require resources that could be used to produce other goods or services. For example, a highway project needs labor, materials, land, and equipment. So once these resources are devoted to the project, they are no longer available for other purposes. So now there's opportunity costs associated with this project, these policies. So conceptually, these costs equal the value of the goods and the services that have been produced had the resources used in carrying them out being used in the second best way, in the best alternative way. Well, in principle, we should measure it this way. Practically, the most obvious and the natural way to measure the value of these resources is simply the direct budgetary outlay needed to purchase them. Think that I want to use truck, okay, in my project, and what's the cost? So in principle, it should be the opportunity cost associated with if I don't use this truck for my project, I can use it elsewhere in the second best or in the best alternative way. For example, say use this truck in building bridge, okay, and what's the opportunity cost of doing so? In practical, we are going to say, okay, this is simply the direct budgetary outlay needed to purchase this truck. For example, it cost me $50,000, and $50,000 is the cost I'm going to use in the NPV calculations. This is the case, or the budgetary outlay is equal to opportunity costs if markets are efficient with negligible price effect. Supply curve is perfectly elastic. Okay, the supply curve is horizontal. Okay, and this is a demand for a truck without the project. This is demand for a truck with the project, and the costs of the project and the cost of purchasing trucks for my project is just equal to the price times the quantity. And it's not the case if supply is perfectly inelastic, is horizontal. Okay, these are the principles we want to follow in valuing the benefits and costs associated with a project.